This is the 6-5 and 7-7 review number 5. It's the free response problem, and calculators are not allowed. So on this particular problem, we see that we're getting a little bit of that fundamental theorem of calculus coming into play because we have defined g of x as 3 plus the accumulation of this picture. So we're going to have to do some of that 5-3 skill in addition to the 6-5 and 7-7. So part A, we want g of 8, g prime of 8, and g double prime of 8. Well, g of 8 will be 3 plus the accumulation from 8 to 8 on that function. And we know accumulations, when we don't go anywhere, give us 0, so we'll just end up with a 3. G prime of 8 is going to require us to take the derivative of this function. So I'm going to go ahead and write down what g prime is up here, and I'll also write what g double prime is. So g prime, I'll take the derivative of the 3, which is 0, and then I'll hit the integral. And remember, when you hit an integral and you're taking the derivative of it, you're going to dump that top letter into the function inside. So we'll just get an f of x. That means the second derivative of g is the same as the first derivative of f. What that means picture-wise is that the derivative of g is the output on the picture, and the second derivative of g will be the slope of the picture. So if we want g prime of 8, we're looking for f of 8, which is the output of this function when I plug 8 in, and I get a 1. If I want g double prime of 8, that means I'm asking for the slope of this picture at 8, and we can see that that is 0. If we look at part B now, it says on what interval is g decreasing, and we want to justify it. So g will decrease when g prime, which is the same as f, is less than 0. So we're looking for values of f that are negative, or values of f on the picture that are below the x-axis. So we can see that this occurs on the interval from -2 until 2, and then again from 14 to 18. Next part, C, says on what intervals is the graph of g concave down. So we write g is concave down when g double prime, which is the same as f prime, is less than 0. So that means we need to be looking for when the slope of the picture up above is negative. So this is going to occur first here from 6 until 8, and then again from, it's like 10 until 18. So we can write down 6 to 8, and those will be soft brackets, and then we'll pick up again at 10, and we continue all the way to 18. And notice I'm going to include the 18 because the slope at 18 did not level out and become 0. It's still negative. Okay, last part, D, find a trapezoidal approximation using the 5 subintervals of length delta t equals 4. So we want to go from -2 to 18. Let's remember that if I'm approximating that, I will have 1/2 b minus a over n, which is going to be 5 times f of my first endpoint plus 2 f's of my second edge, which will be a -2 plus 4, plus 2 times my next one, which will be that one plus 4, plus 2 times my next one, which would be 10, 2 times my next one, which would be 14, and notice that one more addition of that delta t is going to get me up to the 18, and I only get to use the edges one time. So I have double all the interiors because those get used on the trapezoid to the left and the trapezoid to the right, but here on the edges I just have the one. So if I finish this up, I have an 18 minus 2, that's a 20 divided by 5. Well, there's that delta t, which was 4. So I have a 1/2 times a 4 is a 2. And then I have f of negative 2. These are all outputs of the original function. So I'm going to go up and look at the graph. You can see that f of negative 2 is a negative 1. F of 2 is 0. F of 6 is a 3. Then 10 is also a 3. 14 is a 0. And then 18 is a negative 1. So I'm going to go back down to the picture, or down to part D, and write that all in. So I'll have f of negative 2, which was a negative 1, 2 of the f of 2's, which were 0, 2 of the f of 6's, which were 3, 2 of the f of 10's, which were also 3, 2 of the f of 14's, which were 0, and 1 of the f of 18's. Put that all together, I get a negative 1 plus a 6. Oops, that should have been a 3 here. Negative 1 plus a 6, that's a 5, plus another 6 is an 11. Minus 1 gives me 10 times 2 is a 20. And we are done.